What's up guys, welcome back to the channel. In this particular video I will explain the problem minimum multiplications to reach end. This problem is again an interesting problem, and guys I want you to stay tuned till the end of the video so that at last you will have complete idea about how this problem can be solved. Starting right away from the problem statement, so it says that given start and an array ARR of n numbers. At each step, start is multiplied with any number in the array, and then mod operation with 1 lakh is done to get the new start. And your task is to find the minimum steps in which AND can be achieved starting from the start. If in case it is not possible to reach the AND, then you can simply written -1. Okay, so guys, let me explain the problem with a given example. So according to the problem, we are given start and an array which contains n numbers. So for this case, you can see that it contains 3 numbers, right? So n equals to 3. At each step, we can multiply the start with any numbers in the array. So I have 3 numbers and I can multiply start with any number, right? And then I have to do mod operation with 1 lakh so that like any multiplication result doesn't exceed this particular value, right? After this, our task is to return the minimum steps. So for this example guys, what I can do is I can simply multiply this particular number 3, which is our start. We can multiply this number with 2, right? So if I multiply this number by 2, so I will, and then I can perform like mod with 1 lakh, right? So I will perform mod, and this way I will get my result as 6, right? So this 6 is going to be my new start. After this, again I can repeat the steps. So this is step 1, this is step 1, and after this I can again perform the same step. So what I can do is I can multiply this particular number 6 with any number in the array. So let me choose 5 now. So if I multiply this number with 5 and then I perform mod with 1 lakh again, so this way I will be able to get 3 as my output. And guys, now you can see that our end was 3, right? And the main goal is to reach end from start. So now you can see that starting from start I have reached end in just 2 steps. So this is my first step, this is my second step. So we can like get our result in 2 steps. So 2 is going to be the output for this particular example. Now I hope you have understood the problem well. So let's talk about the solution now. Okay, so I have written one example here, and guys, I'm going to use this particular example in order to explain you the approach. I just want you to pay attention and watch everything carefully. So for now, just forget about the whole problem that we have. We are specifically going to talk about this particular example, guys, and we will definitely generalize the approach once we have understood the approach, right? So my first question to you is, how as a beginner you are going to solve this particular example? I'm not talking about any programming concept, any algorithm or anything else here, right? I'm just talking about how you are going to solve this particular example. So let me explain how I as a programmer will solve this particular example, and guys, you will definitely agree with whatever I'm saying, right? So we have start equals to 3, right? And the problem says that we can multiply this particular start with any number in the array. So let me try multiplying this particular start with every number, right? And if I get my result, so I will definitely return that particular answer. So we are actually going to explore, we are going to explore every possible possible way, right? And this is what the brute force says. Okay, so how we are going to explore every possible way? So I have start equals to 3. So let me call it steps that I have performed till now is 0, right? At step 1, I can try multiplying this particular number 3 with every possible number in the array, right? So I will have 15 here, then I will have 12 here, and I will have 45 here, isn't it guys? Okay, so even you can see that after performing step 1, I'm not able to get my answer, right? So for these particular values, because these values are going to act as a new start, this is what the problem says. The problem says that multiply start with any number in the array and then perform mod with 1 lakh also, right? And then we will get our new start. Okay, so we are missing one step here. We have to perform mod with 1000, okay, 1 lakh as well. So we are going to perform mod, and whenever we have a value which is smaller than 1 lakh and we are going to perform mod with 1 lakh, so we are going to get the same value, right? So we are going to get same result after performing the mod. After this, guys, I will again multiply these new start with every value in the array, right? So what is the first value? First value we have is 5. So 15 into 5 is 75. Then 15 into 4 will give me 60, right? And 15 into 15 will give me 225. After this, I have 12 here. So let me multiply this 12 with every number also. So when I multiply 12 with 5, so I will get 60, then I will get 48 for this, then I will get 180 for this. After this, I have 45 here. So again, try multiplying 45 with every number in the array. So if I multiply 45 with 5, then I will get okay, so let me multiply manually here. 45 into 5 will give me 25, then 2 here, then 225, right? I will get 225 here. After this, I have 45 into 4. So 45 into 4 is 180. After this, I have 45 into 15. This is nothing but 675, right? So guys, still you can see that we are not able to get our end result, which is our 300, right? So again we can try multiplying these numbers with every possible number in the array, but before that let me write step 2 here. So this is the result of step 2, right? This is the result of step 2. Now let me start with 75. So first of all I will multiply 75 with this particular number, so I will get 375. After this, I will multiply 75 with 4, so I will get 300. And now you can see that this 300 is equal to our end, right? So how many steps we have performed? This is step 1, this is step 2, and this is the result of step 3. So we can get our answer in just 3 steps. So 3 is going to be the output for this particular example. Now guys, we are going to observe many things from this particular explanation, and this is going to be the approach for this particular solution, right? How how we are solving this problem, let me explain. So you can think of this particular like diagram as an n-Ary tree, isn't it guys? So we can think of this particular diagram as an n-Ary tree, and I guess you guys are aware of a tree data structure, right? So what we are doing is we are traversing this n-Ary tree level by level, isn't it? So I have start equals to 3, then this is the second level, which is our step 1, right? And this is our third level, this is our fourth level. Even if we follow zero based indexing, then this is our zeroth level, this is our level 1, this is our level 2, and this is our level 3, right? So what we can do is, how we can explore every possible way. So we can think of like this particular diagram as an n-Ary tree, and we can perform level order traversal in this tree. Level order traversal, right? Traversal. Guys, level order traversal for a tree is is not main part of this video, so I'm not going to explain level order traversal for n-Ary tree in very detail, but I will definitely explain this particular topic in brief, right? So let me explain how level order. Okay, now what I'll do is I'll simply start with okay, so a tree. I have to draw a tree. I have this as the root node. After this, I have like let's say I have 3 children here, then I have 3 children again, and for this I have only 2 children, and for this I have 4 children, right? So this is how an n-Ary tree looks like, and of course we are going to have some more levels here, right? So there is no any definite number of levels. So how we perform a level order traversal for this, guys? If you have performed level order traversal for a binary tree, then you will have an idea that queue data structure is used, right? So we are going to use a queue whose name is queue, right? So we have a queue data structure, and in this we are first going to store the root. So I will say that okay, queue dot add root, right? After this, while queue is not empty, this is how we perform level order traversal, right? So while queue is not empty, I will simply do one thing. I will traverse the whole level in one go, right? So right now queue is storing only one element, and this element is basically representing the zeroth level, right? So what I'll do is I'll simply extract the queue size. So size equal to queue dot size, and we are going to traverse this particular queue in one go. So I have to start a loop for I equals to 0, then I smaller than size, and then I plus plus, right? Inside this, what I'll do is I will have every element of the queue that queue is currently storing. So I have only one element, which is root, right? So I will extract that element. I'll say that okay, my current node is equal to queue dot poll. Q dot poll, or we say Q dot pop, both means the same. I'm actually enqueuing and dequeuing an element, right? So I hope you guys are aware of dequeue operation in a queue, right? Okay, so now I will get my current. I will simply say that okay, now I have current, so I can try out multiplying this particular current start with every possible number in the array. So again I have to do one traversal for every number, for element in array, right? For every number in array, inside this, okay, why I'm saying every number, actually in binary tree what we do is we simply check for left and right child, right? Because we have only two child, we can check it manually. But for n-Ary tree we have n child, right? And we have to do for every child one by one. So that's why I'm again starting a loop. This is how we perform level order traversal in an n-Ary tree. Inside this, see guys, inside this what we are going to do is we are going to try multiplying this particular start with every number in the array. So element is representing the number and current is representing the start. Let me name it start even, right? So start. So what I'll do is I'll say that, okay, new start equal to start multiplied with element, right? This is what I can do. And of course I have to perform mod as well. And after this I will simply add this particular value in the queue, because this is something that we need to do, guys. This is the part of algorithm, that whenever we get a new value or a new child, so we have to add that particular child in the queue. This is how we perform level order traversal. So I'll simply say that queue dot add new start, right? New start. So this is the approach that we are going to follow. This is not the exact approach, guys. This is a similar approach, right? We need a level variable as well. This is going to keep track of level, right? So once we are done with this particular queue traversal, this part, then we are going to do level plus plus, right? Okay, let me remove this, guys. Let me remove this. I'm going to write it more clear. So I will simply do level plus plus here. This is a similar approach. And of course, whenever we extract a start, so we are going to check if my start is equal to end, right? Once this particular condition is reached, then I can simply return level. This is all we need to do, guys. And now at last, if the condition is not reached everywhere, I have not written level anywhere, so I'm simply going to return -1. This is not looking so good, guys, but when I will show you the implementation, then you will get a more clear idea, right? But before that, I want you to notice one more thing. See, from this dry run, we can see one thing, guys, that we have repeated sub problems, right? We have repeated sub problems. Even you can see this 180 I have two times, right? So my question is, if we are solving for this 180, so why we are solving for this 180? Because whenever I multiply this 180 with these particular elements, so I will get same result in both sides, right? So we can avoid solving the same problem again, right? We can avoid solving the same problem. So how we can do this? In order to do this, we can use a visited array, isn't it, guys? We can use a visited array, and whenever we will calculate our new start here, so we will check if new start is visited, right? Only in that particular case we are going to add new start. Like if new start is not visited, then we will add new start, and else we will simply continue the loop, right, without adding new start to the queue. So this is what we can do in order to solve the problem, guys. So let me write the whole approach in a clear manner. So we have level equals to 0, level equals to 0. After this we have a queue, right? So we have a queue, and we are declaring a queue here. After this we will first add a root to the queue. So root is nothing but our start, right? You can see here as well, start is basically the root that we have. After this, guys, what we will do is I will start a loop while my queue is not empty, so not queue dot empty. After this, inside this particular loop, we are first going to extract, like we are first going to traverse the queue in one go, right? This is what we do. So I'll say that int size equal to queue dot size, right? After this, what I'll do is I'll simply again start a loop for I equals to 0, then I smaller than size, then I plus plus, right? And of course, guys, we are going to have a visited array as well. So let me declare a visited array here as well, right? This is a visited array of Boolean type. So inside this, first of all, I will extract whatever value is present in the queue. So let me name it start. Start is basically equals to, okay, let me name it start, because we have already st variable here. So this is q dot poll, right? This is how we do in Java. Of course, we have different syntax for different languages, right? For C++, we have pop first, then we remove the value. Okay, after this, we are simply going to check if my start is equal to end. If this is the condition, then we can simply return level variable, right? Level is basically going to represent the steps. You can even see here, guys, level was representing the step, right? We have 0th level, first level, second and third level, and 3 was output for this particular example. After this, again, I can add every particular, like I can explore every particular way, like I can traverse the array. I can traverse this particular array, and then I can multiply the array element with start, right? So this is what we can do, guys. I'll say that for every element in array, I can simply do what? I can simply like multiply the array. So I will have a new start here, and then new start is nothing but start into element, right? This is what we can do, and after this we have to do mod with 1 lakh as well. So guys, this is something that we can do. After this, we are simply going to check if my visited of new start is equal to false, right? Only in that particular case we are going to do q dot add new start. This is what we can do, and we have to keep track of level as well. So I'll do level plus plus here. So guys, this is the approach that we are going to follow. What is the time complexity? Now we are going to discuss about time complexity, right? Time complexity and space complexity. So see, guys, this particular tree, every time is going to store every possible value of start, right? And what is the maximum possible value of start that we can have? Start can have value from 1 to 1 lakh only. Why I'm saying this? Because every time we are doing mod with 1 lakh, right? We are doing mod with 1 lakh here, and this is something that bounds start to this particular range. And if start has only this value and this tree, and we are traversing this tree, right? So we are not going to traverse more than 1 lakh value. So the time complexity will be O of 10 raised to the power 5, right? This is about the time complexity because we are traversing this tree only. And after this, talking about the space complexity, so we have a visited array of 10 raised to the power 5. So space complexity is going to be O of 10 raised to the power 5 here, right? Guys, this is about time and space complexity. Let me show you the code now. Okay, so I have the C++ code on the left hand side, and now I have the Java code on the right hand side, and I have written the Python code as well. Guys, when I was writing pseudocode, then it was not very clearly visible. So now you can see everything clearly, right? We have level variable, then we are declaring a visited array and filling it with false value, right? After this, we are simply performing level order traversal for an n-Ary tree. And if you see the topic tags of this problem, then you will find that BFS is given at as the topic tag. And guys, level order traversal is nothing but BFS, right? You can see here that BFS traversal. If you see the topic tag, then it's saying graph BFS. Why it's saying graph and BFS? Let me show you. Because a tree is nothing but a special case of graph, guys, right? And BFS is very similar to, and even BFS for any tree is nothing but level order traversal, right? And we have n-Ary tree here. So this is about the code, guys. Now I hope everything related to this particular problem is clear to you, right? This is the Python code that we have. So now I hope everything related to this problem is clear to you. This is all about this video, guys. Thank you.